Welcome! In this video we will look at the use of tree controls with the PowerBasic Windows Compiler. Tree controls can be a very useful way of displaying hierarchical information. We're looking at a tree control right now. Your File Explorer in Windows is a combination of tree controls. So how can we make use of that functionality within our own applications? Let's have a look at the code. What we have here is a very basic form, and if we look inside our form designer, we will see it's a plain form with a single exit button. Now we're going to add a tree control to this. In the toolbox is a tree control. If we double click on that one, it will create a tree control for us, and we can position and size it on screen. If we just take that as default, we save that and we go back to our code. Let's see what it's changed. If we have a look at the dialog itself, we'll see that there's now a new command, control add tree view, giving the tree view a handle and a location on screen. Now, in order to put some data into our tree control, we'll have to do some work. So in the initialization of the form, we will call two functions. Populate tree and build our tree. Populate tree will provide the data that's going to go into our tree, and the build our tree will actually take that data and slot it into the tree control. Now we're going to have to pass some parameters here. So in our builder tree, we're giving it the handle of the dialog and the handle of the tree view control itself. There's the skeleton of our two functions in place. So first one we'll look at is actually populating the tree with some data. The first one we'll look at is our function which is going to provide the data which is going to be populated into our tree. Now, the first thing we're going to do is we're going to need an array to hold this information. What I'm going to do is I'm going to create an array that's going to contain hierarchical data. Say for example the people who work for a company, to show the company hierarchy. So we're going to put this into a global array. So let's set up our global array first of all. As a string array. So our first task is to redimension the string array, and we'll give it 10 elements to begin with. This information, of course, could be pulled from a database or a spreadsheet or any other place you have the information. So what I'm going to do initially, I'm going to populate two elements of that. The first element being the name of our company and the name of the top person in the company. And the second element being the company, the top person in the company, and the person who reports to that top person in the company. A very simple hierarchical structure, and this is what we want to actually display in our tree control. I'm going to use a new library in this program, basically to handle the parsing of strings. So we nip into our libraries, and we will see our new library is PB Common Strings. Now there's only one function in there at the moment, but this will be a library that can be used both for the Windows compiler and the console compiler. Right, let's just compile that, and it compiles it cleanly. Now the program doesn't do much at the moment. If we have a look at our event handler, we've completed the populate our tree for the moment. Now our next task is actually to build the tree. So we're taking in two parameters. We're taking in the handle to the dialog and the handle to the tree control itself. So the very first thing to do is to make sure that the tree control is in fact completely empty. The tree view reset command will remove any data that's in the tree at the moment and leave you with an empty tree. The next thing to do is we have all our data in an array. We will do a quick sort on the array using the array sort command or our str data, and we'll collate it in uppercase as ascending. That way it doesn't matter what order the data comes in, it will always be sorted by the time we get to this point. Now to populate the tree, we're going to go for each element within that array. So we're going to need a for next loop, and we'll need some variables for this. So the for next loop will loop round each element in the array using the ubound command to work out how big the array actually is. Now I'm going to pick up the value that's in that element array, and we're going to put this in total work variable just to make it easy to follow. So that's picking up the element we're actually pointing at. Now if the data in that element is completely blank, we'll just basically skip over it. And we can use the iterate command for that. When it reaches this line of code and str work is 0, then the iterate command will basically iterate to the next loop, which will take to the next star. So if the first element is blank, it'll go to the second element. If it's blank, it'll go to the third. And it'll keep doing that until it finds something that's not blank. Now we want to pick up the total number of elements in that string. Now that string, as we saw, is going to have 2 elements for the first one and 3 elements for the next. So we'll need a counter to work out where we are. So we'll use one called total elements, and we will pick up at this point the total number of elements. And we'll use the very useful parse count command. And parse count will count how many slashes there are and come back with the number of elements, which is perfect. Now once we've actually got that, we'll need to do another for next loop for each of these elements. So we'll have another variable, long C, and a for next loop for that. And this is going to go up until the total number of elements. Now when we get to this point, we need to work out nodes, because each node, each root node of the tree will be the first one, and anything else we'll treat that as a parent. So we're going to do a select statement based on long C. And we're going to put that information into another variable called str data, which we'll declare up here. And we'll use the parse command to pull that information out. So since we've stored the information in str work, we'll use the slash command and the long C command to pick up that particular piece of data. Now we may actually come across that piece of data several times, so we need to work out whether we already have details of that node or not. And we can use the array scan command, and we'll want to scan another array which we haven't got yet, and this will be one to keep track of the node names. So we're going to dimension another array. In fact, we'll dimension 2 additional arrays. One to keep track of the names, which is a string in the node, and one to keep track of the number of the node. So if we scan that, we'll be scanning it again in a case independent search, looking for str data. And if we do find anything, we're going to pass it into this temporary variable, which I will declare up here. And if this value is 0, it means we have not found the element we're looking for. So this is where we will actually insert data into the tree itself. Using the tree view insert item command. Now we're passing it the dialog handle, the handle to the tree control, a 0 to say it's going to be in the root of the control, and in this case we'll be wanting everything sorted, so I'm going to put in the constant for TVI sort. Now the next two parameters are to do with images in the tree control, which we'll cover later, so we'll put that in as 0 for the moment. str data is the information we want to put it in, and we want to pass that out to a handle, which is the node pointer, and we want to store that value. So let's just create another variable for that. Now, having got that handle number, we've put the data into the tree and we want to store it. And we're storing it in the node arrays. So first thing to do is to read using the preserve option. First of all, the string nodes. So what we're doing in that command is we're redimming the str nodes array, which is a string array. We're preserving the information that's in it. We're recreating it from 1 to the upper bounding of what it is at the moment, plus 1. So basically we're adding one element onto that array without losing any information. And then into that value, we're putting the data. And we're going to do exactly the same thing with the numeric array, which is going to store the handle that the tree control has just given us back. We're preserving it, plus 1. We're taking the value of our handle and we're putting it into the highest element. So we're storing two pieces of information, the string data and the handle. That handles everything for the first part. The next part is where it's not the first element of the string. We've handled case 1. This is for everything else. So in this case we will already added a node and we need to know where to attach our new element. So same as before, we're picking up the str data, which is the information we wish to add, and we're going to be using the function in our new library to find out what the payment is. What it's basically doing in this function, if we look back at where we populated our tree, we'll see in here that if we're processing this one, then basically we want this piece of information. If we're processing this one, then we need this information. And this fun start range parse function makes that job very much easier. We're passing into it the str work, which is the entire path. We want everything up until the element before the one we're actually working on. That common function will save us a bit of coding. And then having got the payment, we then have to scan our str nodes to find out where that one sits. So the information for the payment will already be in that node, and again, if it's greater than 0, it will have found it. So we want to pick up what the payment value actually is in the numeric array, and we'll need a variable for that declared. So having got the parent, we can then scan again and do our test again. And if it's not found, then we're going to insert the node. This double checking is necessary because you wouldn't want to duplicate the entries in your tree. And again, we're using a tree view. And we're using each parent this time because we know the parent handle. And we're using TVI last. And again, we're 2 zeros here because we don't have an image list in here for any images in the tree control. And the data we're putting in, and again we're storing that in a handle. Now I'm also going to put in an expand command so that the tree view will be automatically expanded. That's quite simply passing the dialog handle, the handle for the tree control, the parent, which we've just cut short with the parent, and a true to say we wish to have it expanded. If that was set to false, then it would not be expanded. It would be basically collapsed. And again, we need to add this newly added node to our nodes tree, exactly as we did before. Redimming, adding 1 with the preserve option, putting the data in, and the same with the numeric value. Now, having got all that in place, let's just do a quick compile to see we haven't missed anything. We've forgotten to declare one of our variables. Oh yes, there should be a comma after the case. And there should be one there as well. Right, we've got it clean. We try running that now. Right, our problem there was we hadn't properly dimensioned our nodes. We need to have something in it before we start, otherwise it will be dealing with an empty array. So if we try running our program now, our tree control will come up with company at the top, then Susan Gold, and then Tom Copper. So if we expand our data to give us a bit more to work on, and we'll add a few more members of staff onto this list, and we run that now, and our array is quite bigger now. Given the routine we're using, this is enough for it to work out what the company hierarchy actually is. And you can quite happily, as in any tree control, collapse any of the elements of the tree or expand them. So that's a basic tree control, giving it basic data. Tree controls are quite flexible though, and as you've seen from using File Explorer, you can have icons in there as well. So how do we add icons? Well, what we're going to do is we're going to add some icons in here. Now I've created 2 icons in our folder. If we have a look in here, A icon and B icon. We're going to use those to appear in our tree control. So we need to create an image list. And we're saying this image list is going to be for icons. It's going to be for an icon that's 16 by 16, 32-bit colors, and the 10 will be the initial number of items on the image list. And we use the to command to send it towards the handle of our image list. Now we'll need to create that as a global, and I'll do that shortly. But if we put 2 further lines to add our icons, and since they are in the root of our folder, we'll just slot them in here. As so. So let's create a global for this. Up where the rest of our globals are. Right, having got our images in, we now have to go in and attach this to the tree control. So if we have a look at our builder tree, now this is where we first reference the tree, and once we've reset it, we can go in and attach our image list. Now, having attached our image list, we now have to tell the program where we want these images appearing. Now, the tree view insert item, we said before, had two numbers in it, 2 zeros. Now, since the image list is already started, if we put 1, 1 in there, it will pick the first image, and down here where we have the second insert item, we'll put 2, 2 in to pick the second image. And if we run that program as it stands, our image list will pop up, now with icons. The first icon is appearing on the root element, and the rest have the second icon. You can put a number of icons in to designate different things, say for example departments, or perhaps permanent and temporary staff. So this is just an introduction to what you can do with tree controls. But that's it for today. We'll leave the more complicated bits for a later video. Thank you for watching.